So thank you everyone for joining this talk that is, it's a topic, blends two topics, one which I've been passionate about for a long time, data visualization, and lately been blending this with accessibility and dealing with the special challenges that we have there. Folks are still able to hear me? I think you are.
Yes.
Great, okay. So I want to start off with a story about Mona Mankara. Mona Mankara was when she was a 6-year-old girl, she knew that she loved STEM activities. She loved science, math and engineering. And when she was 7 years old, she was diagnosed with macular degeneration and cone rod dystrophy, and was told that she would go blind. And she did. She began the process of going blind. And her mother was told by specialists that there was really no point in investing in her education too much, because it was impractical to think that she was going to be able to pursue her dreams as a scientist. Today, so she went on to become, to get her PhD in chemistry, and today is a professor of bioengineering at Northeastern University in Boston. She is helping develop and find pedagogical applications for tactile graphics that she uses in her classes. So she uses a method where most of her students are sighted, and it's a way of using something called lithophanes that I'll talk about in a few minutes to take thin sheets of material that have gradients of a raised surface to where people can feel the image by the touch, and then sighted people can hold it up to where light shines through it and they can see the image as well, and uses this with a scientific application. And this is something being developed by Brian Shaw at Baylor University. She's at Northeastern University. I open up with that story to talk about the importance of sighted people, blind people, and everyone who wants to be able to gain data insights, being able to have a shared experience, and us with abled people being able to benefit from brilliant folks who are able to use some type of method in order to communicate things. So this brings us to kind of the core topic, is data visualization, which is all about data communication. We talk about visualization because that's what we've adapted things to, since our species is, based largely around vision. We gear it toward data visualization, but the core point is communication of insights. And so let's do a quick review of sort of the current state of the world in terms of data communication. This first image, by the way, I'm going to do my best to describe the screens that are showing as I'm going through this. So if I forget, please remind me if I go too far without describing it. So right now we're looking at a screen with a lot of fancy data visualizations and a lot of stuff going on. So the state of kind of data visualization now is better than it's been before, but it really is a lot of malpractice used in data visualization for sighted people, even. So graphics are often created to entertain. People think that data is boring and that there's a need to spice it up. The result is we use visualizations that are more aligned with the goals of data art rather than data visualization, which is revolves around communication. So that's kind of the state of things. Like I said, it's gotten better over the years. A lot of news sites, especially around data that the general public needs to gain, like around polling or around weather storms, actually has gotten a lot more decent over the years, but there still is much to be desired. This next example I'm going to show is what someone using an assistive technology would experience if they're looking at a dashboard. I'm going to play this. It is a stream of a stream, which isn't great, but hopefully you'll be able to hear it and get the gist of it. Folks may have heard this before, but it's basically a screen reader assisting a user with interpreting a dashboard screen. Essentially, what you're hearing there is the screen reader reading through the data points of the data visualization. So the user is navigating around to parts of the screen, and it's the screen reader is reading the points. The point there is that the person who's using the assistive technology is experiencing this visualization as a series of data points, really the same way you would experience it if you were looking at a table. Really not much of a difference, and not getting the same kind of benefit that people would be using from a visualization. This one I won't be able to play, but this is sonification. Let me see if I can actually post. This one's not on YouTube either, but if you can see enough of these clips, one sonification at highcharts.com, that's the kind of sine wave that you're looking at here. So if you go to sonification.highcharts.com, HighCharts is a data discovery tool that is working on sonification modules. Essentially what it is it's a method of playing the data like as if it was, like music or something like that. And then there's another example from SoundCloud. If you could, read a little bit of that URL, you'll be able to see it. But it's a example of a sonification of seismic data. Looks, I think I can hear somebody. I don't know if someone's speaker was off, but if you want to let me know something, you could also post it in the chat, and I think I'll be able to see it. So sonification may have some useful applications. It really is about, creating an audio experience directly out of the data. It's very likely that this, we'll see where it develops, but will probably require quite a bit of training. And because there might be a learning curve that, we can see where it goes from a scalability standpoint. I think the biggest issue that I would identify with sonification is the lack of standardization around it. It's sort of all over the place. For example, there's no consistent way of viewing, so up versus down is fairly obvious. You change the pitch of the sound, but there's other aspects of things that maybe are not totally worked out. The different types of instruments and things like that are used to play these sounds. And so that's something to think about. It might be interesting, might be exciting, but probably not scalable for our purposes of what we're getting into today. The last one I want to talk about is lithophanes. It's in an area called tactile graphics. And that's the story that I opened up with Mona Munkara. So what is being used in that capacity is graphics that can be experienced both by sighted people, blind people, and are able to be directly experienced. Obviously, this would have scalability problems, right? Because we don't have a way of dynamically, for example, transmitting tactile graphics. Perhaps somebody could invent some form of like a Braille keyboard where you're able to do these kinds of things, but with graphics. But as far as today, I do not think that it's probably terribly scalable as a method. But the reason why, one aspect I want us to pull from this lithophane tactile graphics method is it is an attempt to create something that can be both perceived by folks who are and are not using the assistive technology, right? So it has both the assistive interface and the regular interface, right? So a sighted person can hold up a lithophane and to the light and they can see the image. And someone who's using it in a tactile manner can actually touch the surface of it. It's the same, it's two different aspects of the same interface. And I think that the solution that I'll propose and go over later on in this talk, I'm going to discuss a solution that I think has the same conceptual features to it. So that is a little bit about where we are, and it's being researched. These are a few pictures of the lithophanes being used where you're holding up this this sort of this image to the light and able to see things. And this is a screenshot that came out of a research paper where the effectiveness of this is being investigated to see how we might be able to learn how effective this stuff is, in other words. So an exciting frontier, but maybe not as scalable as we would like for digital interfaces at this point. So the purpose of data visualization, let's make sure we're grounded in the real purpose of this, which is gaining insights, transmitting insights from one human mind to the next. That's ultimately what we're trying to do. And so for the topics of the rest of this presentation, I'm going to go over, there's a whole bunch of subtopics in data visualization by itself and accessibility by itself. They're both gigantic fields with a whole bunch of subtopics. So I've kind of put together a little bit of a framework for trying to think about these things and to be able to wrap our minds around all of it. And grounding ourselves in the purpose of data visualization, taking a quick look at the history and where that guides us today, understanding the true problems, and then proposing what I hope might be a method. So a whole bunch of topics: signal detection theory, how do we process things in a serial manner, sometimes in a parallel manner, sometimes a whole bunch of topics. But if we organize it in sort of a framework like this, right now, for people who are not seeing the slide, I'm showing sort of a grid table where left to right, it's kind of a diagram. For left to right, we're going from raw data all the way to a visualization, all the way to make something easy to interpret. And then going up like rungs of a ladder from the bottom, we're starting at sighted people at the bottom, where we need to get at least the basic level achieved, and going up rungs of a ladder where we're adding layers of facilitation where we create an interface, but to make sure that this is an interface that everybody can benefit from, there are layers of consideration that we want to make sure that on top of the basis that we're achieving at the same time. And the reason why I point this out, even though technically you're supposed to pursue all of these simultaneously, data visualization by itself is often just not done in an effective way that can be communicated. So that's why I have kind of like at the bottom, at least get it in a point where somebody can tell what's going on with these data visualizations. All right, so we're going from bits of data that's in tables, and going all the way to a visualization at the end. Data visualization itself is already a form of accessibility. Humans are not good at interpreting data that's sitting in tables, right? And just rows and columns. That works well for us in terms of looking up data, but it does not work well if we're trying to glean high-level insights from the data. We need to put it into a different format where things look like shapes and objects and things that we've evolved to be able to see. So already, before we start talking about accessibility, data visualization is already a form of accessibility that was invented and developed by statisticians, starting, really in the 1800s being developed. So that's one way of looking at this, right? It's not even outside of the basic ethic of data visualization. And then as we go up the rungs of these layers of facilitation, we want to consider things about the processing modality and different features of it. So if we're looking at vision allows for lots of parallel processing. You're able to see many things at the same time. Whereas in audio, you're perceiving streams of data where you're getting one piece at a time. That's why it's sometimes frustrating if you're going through an audio interface on a phone and pushing keys. You have to listen to the whole menu until it gets to your part, because it's a serial processing experience that you've got to go through. Signal detection theory, we'll get into that a little bit later. And the ability to summarize data is generally something that everybody on every rung of this ladder can benefit from equally. So yes, the purpose of data visualization is communicating the data from one human mind to the other. I'm just going to quickly go through history here. I've got a visualization that I'm showing right now on the screen. It features a line going from left to right. So the whole graphic goes from left to right, from the past to the future. It's traveling through time from left to right, going forward in time. In the middle, like a horizon, in the middle of this chart, horizontally, there's a line that represents good accessibility, excellent accessibility. This is the perfection that we're working toward. On the outsides of this line, I've got two curved lines, one swooping down from the top, one coming up from the bottom. And this represents two arcs of historical development, and these lines getting closer and closer to the optimal level over time. I put this as a graphic. I don't know if it was worth it with me doing all that explaining, but well, hopefully it means something. So we'll start from data visualization. This has been, of course, developed over time, starting with statisticians coming up with different methods of visualizing data over time. So the bar graph, line graphs, these are invented by folks to take data, tables of data, quantitative data, and putting it in a form where things look like shapes, things look like things that we would see, stuff that we would see when we interact with our environment. That's data visualization. It's gotten better over time, over the years, where cartographers in the early days introduced a lot of methods and techniques for visualizing things. In the 1980s, we have a peak of interest of data visualization. Edward Tufte, one of the grandfathers of the profession, starts publishing a lot of research, starts going to battle with a lot of journalists of his day, saying that they're doing malpractice with data visualization, that they're doing it wrong. And from Edward Tufte, we get a lot of wonderful concepts like data-ink ratio, that you shouldn't have lots of decoration and frivolous things in your graphs, and also chart junk, right? That's what we get from Tufte in the 1980s. In the 90s, we've got statisticians like William Cleveland developing more precise methods around data visualization. In the 2000s, we have Stephen Few, the top data visualizationist probably ever, who has defined the rules and the laws about how do we go about doing this. So in theory, at this point, we know a lot about data visualization and how to do it well. Sadly, in practice, we don't exercise all of these things that we know. And so that's where you see on this graphic that I'm showing, there's a split between data visualization in theory and data visualization in practice. The good news is that we know a lot, and we can visualize quantitative data pretty darn effectively based upon what we know if we apply it. But in practice, we're still not there yet, even before we talk about accessibility. Okay, the other historical arc is the one swooping down from the top. Human factors. Human factors is what evolved into what we really know today as UX. It's making things easy to use. Sort of at the beginning of history, you can begin it at World War II, where people start realizing that it's not worth it to have planes crashing and submarines exploding, because the military devices were not built to be used by humans, right? It's the kind of do as you're told mentality. You're going to learn to use these machines. We're not making it to be, it's centered around the process as told by your commanding officers, where there's a shift in mentality over time of let's make things human-centered, right? So you've got human-centered design, user-centered design rises up as an ethic, first starting in military, then applied in industry over the course of many decades. By the time we get to the 1980s, we've got Jacob Nielsen, Donald Norman, pioneers in UX as we know it today, start doing lots of, in many UX usability, men and women of the time, as practitioners and as researchers, developing a lot of what we've got today at our fingertips to be able to make things more usable. On through the internet in the 2000s, and then lately with mobile devices, makes things a heck of a lot more usable, partly because of the need for accessibility. I want to put this quote here to make this point. This is from Jacob Nielsen in a book, Mobile UX, in 2012. This is a quote that talks about how bad the state of affairs was back then, not that long ago, a little over 10 years ago, with mobile UX. Things were so bad in the research done for this book and most mobile interfaces that it was entertained as an option that you might not even want to pursue having good usability for your mobile interfaces because it's so bad. So the quote says, what should we make of the huge difference in conversion rates between desktop and mobile phones? There are at least two different possible conclusions. The mobile user experience must be horrible. He then goes on to talk about how, if you could optimize for a good experience, there's a lot you could gain from it because there's so many sites that are horrible at it that you could do quite well if you're able to achieve this. The second option he's got is maybe for a lot of these companies, it's just simply not worthy of an investment because maybe people are not using their phones enough for these types of things. You fast forward to a few years later, 2015, 2016, I remember being at a conference, I believe it was a UXBA conference, where there was a panel about accessibility, and the panel was split between, it was researchers and folks with disabilities who use assistive technology. When the question came up of how good is technology today, the overwhelming response is that smartphones do a pretty darn good job nowadays. And so the need for accessibility standards was a rising tide that lifted all ships. Perhaps the same thing could be done for data visualization. Let us hope so. Maybe it would be like these, right now I'm showing a picture of a curb ramp. And this is very often used as an example in accessibility talks. I'm using it here to make the same point, which is that this is a technology that was introduced to help people who needed wheelchair access. But it turns out it helps everybody. We've all walked up these things from time to time, veer to walk up it because it's just slightly easier if you're walking. Also, if you've got a stroller, if you're a parent with a baby, it's easier to roll up the curb ramp than it is to bring it up over the curb. So this is an example of UX accessibility being a tide that raises all ships, and hopefully this is the same for data visualization. So where do we go from here in terms of fixing data visualization? Well, I would like to position this overall problem. Let's isolate this scientifically using signal detection. So first of all, in this framework, we're looking at information or interfaces as relaying bits of information through some modality. Usually it's visual, but it's also audio. Bits of information. Bits are a measure of information, right? Like meters are a measure of length, grams are a measure of weight. Bits are a measure of information. And at any given point in time, you're processing massive amounts of bits of information, mostly automatically. And our goal with this, to make sure that our interfaces are good, is to reduce or eliminate the volume of bits of information that are less relevant, and to boost and increase the salience of the bits of information that are more relevant. So reducing the irrelevance, raising the relevance. This is an overall concept that gets us pretty far, whether we're talking about regular UX or UX with accessibility considerations. So in signal detection theory, right now, I am showing a quadrant where on the left-hand side, we've got the title of the rows of the quadrant that go across. And that is a signal is present or a signal is not present, right? So it's a signal present versus no signal, okay? Signal means something that you care about or something that you're looking out for. The columns across the top, so the columns like going up and down, we've got detected, right? So the person who's using this interface has either detected something or if they have not detected. All right, so signal present versus not present crossed with detected versus not detected. This creates a quadrant where if there's a signal detected and if there's a signal in reality, there is a signal and you detected it, that's called a hit. If there's a signal and you did not detect it, that's called a miss, that you missed the signal. Then looking at the bottom row, if there is not a signal, but you detected something, well, that's a false alarm because there was nothing there, but you said that you saw something or experienced something. If there's no signal and you don't detect anything, that is a correct rejection. So when we look at data visualization or any kind of data communication in this framework, we can get a lot of use out of it and simplification of it. It kind of operates as a unifying theory, doesn't it, right? To be able to encapsulate this in a way that we can easily think about it. So for example, if we are dealing with a data with lots of chart junk and a low data ink ratio, what are we dealing with in terms of signal detection theory, which this whole framework revolves around approaching the world in terms of signals and noise. We're dealing with increased noise, right? So you are increasing people's false alarms, right? By putting attributes, visual attributes in there that are not they're not important to people gaining insights, and raising people's likelihood of having or decreasing the correct rejections. Likewise, if you are not picking the optimal types of graphs that really cater to people's ability to gain insights from that type of data that you're showing, you're decreasing their ability to gain hits or these insights, and you're raising the misses, raising the ability for people to miss things and to fail to get the types of insights that they need. So that's a little bit of a grounding in that. And again, we're looking, let's return to this overall framework that we're trying to communicate data. We're trying to start from these bits of information and bring it to the point where it's either a visualization or something that communicates the insight. So just to quickly recap the earlier examples that we talked about, regular data visualizations are plagued with all kinds of problems. The wrong chart types are picked for things that there are insights in the data, but we're not able to get the insights because the type of chart does not cater to being able to see the types of things that you need to gain from it. There are many of examples of this, using colors wrong, picking the wrong chart types, adding chart junk, and the like. Right now, for folks who are not seeing the slides, I'm flipping through a bunch of slides that are overly fancy and are not catering to insights. And a lot of these things qualify as data art and not data visualization. So a lot of the problems with the examples that we went through, visualizations done wrong. Screen readers are good and for certain things, right? So people who use screen readers, engineer friend of mine, when I was talking about some of the stuff, the need for accessibility and data visualization, pointed out to me that people who use screen readers are pretty darn good at it. They're able to perceive things at a rate and in a way that I can't do. And they can go through the keyboard shortcuts that I find very challenging. And they get pretty far with this, folks who use assistive technology. But that doesn't mean that there aren't significant opportunities for us to increase our ability to communicate through those mediums. So we want to do our best to increase that. And then sonification maybe has a promising future. There's probably applications for sonification that you can imagine, perhaps maybe super complex data that's maybe multivariate, and you need to hear, maybe the sound of it is able to give you some kind of a richness where you're able to gain a gestalt understanding of whatever the data is communicating. But we're probably not there yet, and we're not, I don't think, close to anything scalable. And the same thing with tactile graphics. Has many of the same problems. So I'm going to advocate for the end of this talk that the one promising solution for this might be in just regular plain old captions. And it's really captions and alt text. because this is something that already screen readers are built to be able to pick up on. It's not terribly hard for a person to type these up and to add these to their interface. There's some issues when we talk about dynamic data that we'll get to in a moment, but this is something that that works. Now, there's a method that I'm going to add to this, but the basics of it is that, of course, you've got an HTML structure to the containing page, and there's a certain order that is optimal to being able to assist the screen reader in being able to read what you've got. And so, for example, if you have a dashboard title would be the H1, right? The heading 1. The view title, right? So that's the widgets that are on the dashboard. The name of each chart usually is what it is, a chart or a table. That would be your H2. And your H3 would be your filter, parameters, set, and legend title. And then after that, you'd have your alt text for kind of the image level. What is the image level? And then the caption for the data details. Why captions? It's developed for the screen readers as a technology. It's existing, but we can solve the problem through captions by really just exercising our ability to describe a narrative. Now, this requires us to describe the data at a higher level of abstraction that the screen readers don't currently do. Currently, the screen readers just read each data point of data, but what we want to do is something more. We want to write and describe the data the same way you would describe it if you were communicating with somebody. So for guidelines for how to write these, and I'm going to give you examples, but you want to have a clarity bias when you're writing these. There's different types of biases you can have when you're working. You can have a brevity bias where you're trying to make things brief. You want to shorten it up. Or you could have a comprehensiveness bias where you're trying to be thorough. For this, I would recommend a clarity bias. You're trying to be as excruciatingly clear as possible when you write these things up. You want to focus on summarization. This is where you get to use the thousands years old art of storytelling, human storytelling. So just like data visualization caters to our proclivity to visualize the world and being evolved around that, we as humans are also storytellers and story perceivers, and we're when we're able to leverage that, we can get a lot. And using redundancy when necessary for the sake of clarity. I'm going to breeze past this, but overall, I would recommend having a prioritize the data instead of describing the visualization itself. In other words, the visualization is only a means to an end. You can cut right past the data visualization and describe the data more directly. So you want to focus on that rather than just being hell-bent on describing the data. So here's an example for this graph. For folks who are not seeing the slide, I'm showing a graph that has bars, but I'm actually going to read through the caption and you'll be able to get some from this. Okay, so the caption is as follows. And this could be actually split between caption and alt text technically, but I'm gonna call it the caption here. It's the part that the screen reader would read to accompany the title. All right, for this graph, February jobs 1 month net change is a bar graph ranking industries on job creation. Industries with the highest numbers of job creation are at the top, the lowest are at the bottom. From highest to lowest, the values are as follows. And then the screen reader would go ahead and read each one of the points. So the anatomy of this is as follows. You've got the graph title to start. Okay, so February jobs 1 month net change. That's the name of the graph. Then the next you have the graph type is a bar graph. Then you've got the key objective, ranking industries on job creation. Okay. Then after that, you're orienting the user around the display. Industries from the highest, with the highest numbers of creation are at the top, lowest are at the bottom. So you're orienting, you're allowing somewhat of a parallel processing here because you're giving the user the shape of the data. The same way sighted people are able to benefit from data visualizations, people who are using the assistive technology are able to benefit by getting an overall big picture of the data before you go in and not just reading the bullet points themselves. We can get pretty far if we do this. Let's go through another example here. So we've got the full text that's printed out here, but I'm going to go through it through the anatomy here. Graph title: Rising College Costs is a time series line graph that shows cost of college rising over time, right? So right now we've just gone through graph title, graph type, key objective, right? So we've got the basic idea. Now we're going to go into the orientation of display. The graph compares three types of colleges from the years 1970 to 2020, right? So we're getting a kind of a we're getting a picture of the scope. Then the next part, the three types that's mislabeled full text. That should say something else. The three types of colleges are private, nonprofit, four-year colleges, public four-year colleges, and public two-year colleges. And then you get a data clarification here. I've added another element to where this is a piece that's probably important for being able to accurately perceive this data. I won't go through reading that here, but you can get the idea if you're seeing it. If you're not seeing the slide, essentially anything special about the data, you want to be able to point this out to be able to fast forward someone's ability to understand. So here it says the tuition amount is shown on the y-axis. To be precise, it is the average amount that the student would pay in tuition and fees adjusted for inflation. Then we've got the orientation for the data summary. So before we go into the data, we're orienting the user onto that specifically. The data are in 2019 dollars. Here are the trends from highest to lowest. Now notice here, we're actually not even reading the data points. We're actually just describing each line, because that's how you perceive a line graph. A sighted person does not perceive a line graph one data point at a time. If you want that, look at a table. But if you want to see the shape of the data, you look at a graph. If you're experiencing this through audio, you're going to perhaps benefit from hearing about the shape of the graph. So we've got here public two-year colleges start from about $1,000 in 1970 and rise steadily to around $3,000 or $4,000 in 2020. We've got some questions coming in. This is awesome. Here, question, Thomas. What are some good first steps design team can take to start implementing these sorts of accessibility enhancements across their platform? I think today it would have to be manual, but you would want to, if you have static graphs, you would, this is going to be the easier task where you describe these and test them on folks who are experiencing them in only an audio way, and then see if that matches the kind of insights that you would want to get. Okay, curious how this would map to personal data info from a Fitbit. Yeah, you have different recommendations for data you see daily. Yes, so this gets to the question of dynamic data. That is a nut that needs to be cracked. Now, when I first proposed this last year, this was a little bit further out and it was dependent on manual. ChatGPT dropped, as we all know, in last December. And something like this becomes a lot more possible potentially if we're talking about like language learning models and the ability to describe things. There's still a lot of gaps to be filled, but this is something that I think at least a few folks are starting to work on now. But we do need to deal with the dynamic data. That is the nut that needs to be cracked, where there's a bunch of different components on that. I think it's got to take elements of image processing and feed into some kind of a natural language format in order for us to achieve it. So we're not there yet, but we might be on the precipice of it. We probably are. Have you tested the reception of the caption descriptions of the data? Does it align with their expectations? This is so a great question from Trey Rohde. I have not been able to, I've tested this in tiny, small ways, but I have not done this as an organized test. There are some labs that are thinking about testing this, but I think that is kind of the first order. And I would love to see, perhaps even participate. If you're a researcher, link up with me. And if I'm able to participate, I'd love to. But yes, this definitely needs to be tested so that we can develop standards around this. What you're seeing here is more of a hypothesis, I think, that is only partially tested, but we need to dive into this and do more. I'm going to start wrapping up because I think I'm at the end of time, but I'm going to go through this and see how far I get.
Yeah, Thomas, I was just going to jump in.
The last one I'm showing is a chloropleth map, a map with color scale showing intensity, bipolar scale that shows, well, let me actually use this test out right now and use this audio to see how close I get. Corporate tax rates around the world. We are at time, but feel free to continue answering questions. This room is open for a few more minutes. All right, let me just go through this. So this map, this last example that I've got here describes, goes through our first set of steps: graph title, graph type, choropleth map, or a heat map of a world map. This visualization illustrates corporate tax rate each country in the world, of each country in the world. High rates are displayed with a reddish tone, while low rates are displayed with a bluish tone, right? So we're doing kind of high level descriptions of things. Dark saturated colors are extreme values, and light are moderate values. Then it goes through describing things at high levels, at kind of a pattern level of what's going on the continents and what are the general patterns that you would see. But the idea here is using summaries and storytelling so that people can experience this through an audio modality in a similar way that you would experience it from looking at it, in a more parallel manner where you're able to perceive patterns and not just reading through data points in a serial manner. And this is going to our overall goal of making sure that insights are being experienced by all folks, and that we are able to transmit data, insights from one human mind to the next using what we know about data communication. So that is what I have for you today, and thank you very much for attending.
Yep, well, we are at the scheduled time, but we can still take a couple of questions if you want, Thomas.
Please.
I just want to let everybody know that we did get to the scheduled time end, and we'll have new sessions at the bottom of the hour, but we can ask a couple of questions if that's okay.
Absolutely.
All right, let's see. Just reviewing the chat here. Sean asked, what are some good first steps a design team can take to start implementing these sorts of accessibility enhancements across their platform?
Yeah, so some of these I mixed in the answers to them before I ended the call. But so these ones I think I answered. But folks, ask again if I wasn't clear on any of these. But the overall answer to that question, I think, is that manual is easier than anything dynamic now. Alt text could be leveraged to describe things at the kind of high level, graph level, the way like an image normally would, and then the caption being used for the specific information. Possibly, if you're able to feed in data to get it to feed into that caption and to plug in on your web page, that seems a conceivable way of doing this. And then in terms of technology development, how do we get through either an API, but for that to be installed? But I think it has to be manually, maybe starting with this method that I've talked about today, with breaking it down into a clear anatomy of this description. You could start with mine or do something similar, but going for clarity over all other things. I know, I think you're on mute, Joe.
Sorry, I was on mute. Janice said, I'm curious how this would map to personal data. For example, info from a Fitbit or sleep app. Do you have different recommendations for data you see daily versus data you see once?
To me, I think that's going to the question of dynamic versus static. And that's going to be the big challenge, because right now the description of these deal very heavily on a human mind to describe these. And even there wouldn't be a lot of standardization. So for example, I would describe like this light blue line as kind of a steep rise starting at 1980 from 2020, but there might be a variety of ways of describing that, and some more clear than others. So this does require research. Does your tool use data viz implementation into their product? If so, do you have a favorite that touches on what you've presented? So my favorite tool for data discovery is Tableau, but I know that HighCharts is doing a lot of stuff for accessibility. Tableau actually goes great lengths to have things accessible. HighCharts was the one I showed with the sonification example, but things that do this stuff that I've talked about here automatically, I don't know how they facilitate these kinds of things that we're talking about here. But my favorite data visualization tool is Tableau, because it gets like the most right most of the time. I guess you could also throw in there Looker, which was purchased by Google. So you've got Google Looker or Google Analytics now, which if they're as decent as Looker, was fairly decent and is more accessible now since it's owned by Google.
All right, let's see. Maybe I'll take one more question. Let's see, Trip. I don't think we got to Trip's question. Does your team use a tool for data viz implementation into their product?
Yeah, that's the one I just did.
Oh, that's the one you just did.
Yeah,
all right,
that's the one. Yeah.
Okay, good. And let's see, did you get the one Trey asked if you have any leverage points?
Okay, I like this one. The second, sorry, Trey, for skipping over your one. I saw the first one, not the second one. Yeah. So do you see any leverage points for breaking this into something that blind communities can expand on? Man, that's such a good question. So really, I see it as so Trey, just to make sure that I fully understand it, are you saying that blind communities can directly contribute to? I think in terms of testing. I think in terms of, yeah, I think that if we're able to get folks in the blind community to participate in what they find clear in terms of these data descriptions, and if we're able to have experiments where we're able to compare what does a sighted person get from a visualization, and what does a blind person get from listening to a summary, and are they able to get similar qualities of insights? I think that would be so as research participants and as contributing to the thinking about what nuances or other things we might want to be aware of when we're constructing summaries. Because there might be some things that I'm not aware of. Maybe as a sighted person, I'm describing things in a certain way that makes sense to me, but might not make as much sense to someone who's not normally perceiving the world in that manner. And that's something that we would certainly benefit from the insights there. So I think there are so many opportunities from a research perspective, especially for all of us, to see if we could figure out some standards around this.
All right. Well, thanks so much for sharing your expertise, Thomas. We really appreciate it. And of course, everyone, this will be available as a recording as well. So thank you again. And this one did go over, so we have about 5 minutes until the next set of sessions at the bottom of the hour.
Awesome. Thanks.
All right. Bye-bye, Thomas.
Next time.
Thank you.
Bye.